Imagine this, your company has 10 offices across the world. New York, London, Dubai, Mumbai, Sydney. Teams working across time zones. Customers everywhere. Your data lives in Azure. Your applications run in AWS. Your AI and analytics sit in Google Cloud. Different clouds. Different regions. Different tenants. Now here's the real question. How do you connect everything securely, without creating chaos? This is the reality of the modern enterprise. No company lives in just one data center anymore. HR systems might run in Microsoft 365 and Azure. Customer-facing apps may be built in AWS. Data engineering pipelines might sit in GCP. Developers need testing environments. Production must stay isolated. Subsidiaries may have their own tenants. This is called multi-cloud and multi-tenant architecture. It sounds powerful, and it is. But without the right design, it becomes complex, expensive, and vulnerable. So how do global enterprises make it simple? First, they stop connecting everything randomly. Instead of creating dozens of direct connections between every office and every cloud, they build a central hub. Think of it like a secure digital headquarters. This hub, often in Azure or a primary cloud, handles routing, firewall inspection, monitoring, and security control. Each office and each cloud environment connects into that hub using encrypted tunnels or private connectivity. This is known as a hub-and-spoke model. It prevents network chaos and keeps traffic controlled and visible. For the 10 global offices, smart companies use SD-WAN instead of traditional VPN sprawl. SD-WAN intelligently routes traffic, provides automatic failover, improves performance, and allows centralized control. If one connection drops, traffic reroutes automatically. Users don't even notice. Between Azure, AWS, and GCP, secure private connections are critical. Instead of sending sensitive data across the public internet, enterprises use services like ExpressRoute, Direct Connect, or Cloud Interconnect. When private links are not possible, they use encrypted site-to-site VPNs with strong IPsec encryption. All traffic is encrypted. No exceptions. But connectivity is only half the battle. The real strength comes from security design. Modern enterprises follow a zero-trust model. This means no user, device, or workload is automatically trusted, even inside the network. Every login must be verified. Every device must be compliant. Multi-factor authentication is mandatory. Conditional access policies ensure that risky logins are blocked instantly. Identity becomes the new perimeter. Most organizations centralize identity using a primary identity provider like Entra ID. AWS and GCP are federated to it. This means single sign-on, centralized user control, fast access removal, and complete audit visibility. When someone leaves the company, one click removes access everywhere. Next comes segmentation. Not everything should talk to everything. Production environments are separated from development. Databases are isolated from user networks. Management networks are restricted. Firewalls and security groups strictly control communication paths. If one system is compromised, the attacker cannot move freely. Then comes visibility. You cannot protect what you cannot see. Logs from Azure, AWS, GCP, firewalls, and endpoints are aggregated into a centralized monitoring system or SIEM. Suspicious logins, privilege escalations, abnormal traffic, everything is tracked. Automated alerts notify security teams in real time. Access is tightly controlled using least privilege principles. Engineers are not permanent global admins. Instead, they use role-based access and just-in-time elevation. Access is granted temporarily, for a specific task, and then removed automatically. This dramatically reduces risk. Automation plays a major role in keeping things smooth. Infrastructure is deployed using code. Security baselines are applied automatically. Patching is automated. Compliance scans run continuously. Automation reduces human error, and human error is one of the biggest security risks in multi-cloud environments. Performance also matters. Workloads are deployed in regions close to users to reduce latency. Global load balancers route traffic to the nearest healthy endpoint. If one region fails, another takes over seamlessly. Disaster recovery plans are tested regularly, not just documented. And then there's cost control. Multi-cloud environments can become expensive quickly. Smart enterprises implement tagging policies, budget alerts, reserved capacity planning, and auto-scaling. Resources that are not used are automatically shut down. Visibility prevents waste. When all of this comes together, central identity, secure private connectivity, zero trust security, segmentation, monitoring, automation, and cost governance, something powerful happens. 10 offices across the world start to feel like one secure digital campus. Users collaborate without worrying about where systems are hosted. Applications communicate securely across clouds. Security teams maintain visibility. Leadership gains resilience and scalability. In today's world, companies don't compete locally anymore. They compete globally. And the winners are not the organizations with the most cloud providers. They are the ones who connect them securely, intelligently, and efficiently. Because in the end, multi-cloud isn't about complexity. It's about control.